Section 5.4 continued, factoring quadratic expressions. In this section, we're going to focus on factoring trinomials. We're going to continue factoring, and that means rewriting an expression as the product of its factors. And we did that in Section 5.4, factoring out GCFs. We want to continue factoring, but let's take a look at how we want to end up with when we take a look at a product of its factors. Here, I have an expression x minus 8 times the expression x minus 6. And this is a product of factors for a trinomial. Let's take a look at what the trinomial looks like by foiling. Remember, we have done foiling in Algebra 1. And foiling stands for F for first. That means I take the first term of the first expression and multiply it times the first term in the second expression. O means I take the outer terms in each expression and multiply them together. I stands for multiplying the two inner terms together. And L stands for multiplying the last two terms together. But if we go back into the FOIL itself, the F and the O means I'm just going to distribute the first term of the first expression into the second expression. X times X, X times 6. The I and the L mean I'm just going to take the second term in the first expression and distribute that through the second expression. 8 times X, 8 times 6. Let's follow through with this procedure. X times X is X squared. Outer X times a negative 6 is a negative 6X. Inner, a negative 8 times X is a negative 8X. Last is a negative 8 times a negative 6 is a positive 48. Let's check to see if we can combine like terms. I get X squared. A negative 6X and a negative 8X is a negative 14X plus 48. And there are some things you will notice when we start factoring. I'm going to start with a trinomial that looks very similar to this. My goal is to factor this or break it up into a product of its factors, two expressions. But I can always check to make sure I'm right by foiling back down to that trinomial. Also, when you notice, on this problem I have a negative 8 and a negative 6. In other words, the signs are the same. If they're both negative or both positive, and if my middle terms are like terms, then that means I will add them to get to the middle trinomial term. Also, I kind of make a little joke that when I do FOIL, I end up with a nice smiley face. That makes sure that I get my problem correct. Let's try the second example. When I FOIL, I distribute the first term of the first expression through the second one. Y times Y is Y squared for first. Y times 3, or outer terms distributing, gives me 3Y. My I is inner term, or start distributing the negative 5, gives me a negative 5Y. And my last term, a negative 5 times 3 is a negative 15. And again, I know I'm right because I distributed both. Now I just need to combine like terms as possible. I have my Y squared. 3Y minus 5Y is a minus 2Y minus 15. Again, in this section, I'll start with a trinomial and want to break up that trinomial into the product of its factors. But again, I can check it by foiling to make sure that I ended up with what I started. And in this problem, I have a negative 5 and a positive 3. And when I finally did distribute or FOIL, my two terms on the interior of my trinomial were different signs, therefore I subtracted. This slide demonstrates factoring a trinomial in the form of x squared plus bx plus c. When c is greater than 0, that means it's going to be positive. Also, notice that our coefficient on our x squared is 1. Also, we're going to take a look at a trinomial that has x squared plus bx plus c, where c is less than 0, it will be negative. Again, my coefficient on my leading term, or my x squared, is going to be a positive 1. Here, x squared plus bx plus c, I have x squared. 7x represents the bx. B is 7, the coefficient for that middle term. My constant c is a positive 12. C is greater than 0. When I factor a trinomial, I want it to look in this form. In other words, in descending order of exponents. I have an x squared, x to the first power, and here my variable is not there. I just have a constant. The procedure to factor a trinomial is to put down 2 sets of parentheses. That will represent my product of factors. I know that I need to break up my x term. In other words, what 2 terms or 2 factors can I create that when I multiply them together, I get my x squared? And we know that that will happen when I take x times x. X times x is x squared. Now, I go to my last term. My last term, I will generate the last term and my middle term from that last term. I need to have factors of 12. My factors of 12 need to add up to. That plus sign will be very important to us. That plus sign tells us what I need to do to get my middle term. I need factors of 12, but those factors of 12 must create 12 when I multiply, but they must add to create my middle term of 7. And to do that, we could do a factor tree, or just by our multiplication table, we know that 1 times 12 equals 12. We know that 2 times 6 equals 12. We know that 3 times 4 equals 12 when we multiply. But when I go back through, I know that 1 plus 12 is 13. That doesn't give me 7. I know 2 times 6 is 12, but when I add them, doesn't give me 7. 3 times 4 is 12, but when I add them, because of that symbol, that does give me 7. So I know I need to break up my 12 into 3 and 4. And when I have a plus sign here, that tells me that my signs and each expression have to be the same. Either a negative times a negative to give me a positive, or a positive times a positive to give me a positive. And what determines these signs is the second term's sign. Since it's positive, I need a positive and a positive. Now let me rewrite this. X plus 3, x plus 4. This is a product of its factors. We need to check if we're right. In other words, I need to distribute my x twice through the second expression and my 3 twice through the second expression. In other words, FOIL. First, x times x is x squared. Outer, 4 times x is 4x. Inner, 3 times x is 3x. And last, 3 times 4 is 12. When I combine like terms, I'm going to get x squared plus 7x plus 12. Therefore, I know that the product of my factors is equal to the trinomial x squared plus 7x plus 12. Our next example is in the form of x squared. Negative 5x represents my bx, and minus 24, which is our constant, but here our c is less than 0. I want to start out the same way. I want to create my product of its factors, so I'm going to set up 2 sets of parentheses to represent that. I still need to break up my first term into a product of its factors. What 2 values give me x squared? And that would be x times x gives me x squared. I want to go back to my last term. I want to break that up into its product of its factors. They need to multiply together to give me 24, but that symbol here tells me that the 2 numbers that multiply to give me 24 need to subtract to give me 5, specifically a negative 5. If I go through my factors, 24 times 1. 24 times 1 is 24, but 24 minus 1 does not give me 5. 12 times 2. 12 times 2 does give me 24, but 12 minus 2 does not give me 5. Next, I can go with 6 times 4 is 24. 6 minus 4 does not give me a negative 5. The next one would be 3 times 8. 3 times 8 is 24, and 3 from 8 does give me 5, specifically a negative 5. Therefore, I can find the factors of 24 in this situation to be 8 and 3. And since this is a minus sign at the end, it tells me that my signs on the inside of these expressions need to be a plus minus or a minus plus. And that depends on whether I need to have a negative or positive value for my middle term. In this situation, if I make my 8 positive and my 3 negative, I still will get a negative 24, but my 5 would be positive because a positive 8 minus 3 would give me a positive 5x. Therefore, I need to switch those signs and make this a negative 8 and a positive 3. Now what I do is verify by the FOIL method. So I'm going to rewrite my product of factors, x minus 8 times x plus 3, and now I'll just FOIL, or distribute each term twice through the expression. First, x times x is x squared. Outer, x times a positive 3 is plus 3x. Inner, negative 8 times x is a negative 8x. And last, negative 8 times 3 is a minus 24. Combining like terms, I get my x squared. 3x minus 8x is a negative 5x and a minus 24. Therefore, this expression factors into the product of its factors, x minus 8 times x plus 3. Our next example, we have the trinomial m squared minus 14m plus 40, and we want to factor this trinomial. We have a constant that is greater than 0, so we're going to begin by creating two sets of parentheses for the product of factors. I want to break up the first term, m times m, which will give me m squared. Now, I will break up 40 into two factors that will multiply to 40, but when they add, will give us 14. And I know they need to add because of the addition symbol in front of my constant. So we start 40 times 1 is 40, but that does not give me 14. 2 times 20 is 40. Does not give me 14 when I add. But when I multiply 4 times 10, those factors do give me 40. So I know that I'm going to get 40 from 4 and 10. But also, when I add the two numbers, because of the plus sign, it gives me 14. And recall, with a plus sign, either I end up with a minus, minus, which would give me a negative 4m, and also a negative 10m, which gives me a negative 14. But when I multiply a negative times a negative, it gives me a positive 40. If this was a plus sign in front of the 14, then these two minus signs would go to plus plus, which would still give me a positive 40. We can check that by the FOIL, which gives me first m times m, which is m squared. Outer, which gives me m times a negative 10, a negative 10m. Inner, a minus 4m. And my last, which is a positive 40. When I combine like terms, it gets me my original trinomial. Therefore, my product of factors is correct. Our next trinomial, r squared minus 5r minus 150. Here our constant is a negative 150. Therefore, it is less than 0. That means that when we have our product of factors, two sets of parentheses, that one set will be a plus minus or a minus plus. Let's start with the first term. R squared will break up into r times r. R times r is r squared. Now, I need the factors of 150, two factors, that multiply to 150, but will subtract to achieve my middle term, which is a negative 5. Let's start. 1 times 150, of course, is 150, but will not subtract to a negative 5. Next, 2 times 75. We know is going to give me 150 when I multiply, but is not a minus 5. 3 times 50 is going to give me 150, but is not a negative 5. After that, we can have 5 will be times 30, again is 150, but will not give us a negative 5. And as we work our way up, 1, 2, 3, 5, we could do 6. I think what we know is we're heading to 10 times 15. 10 times 15 is going to give me 150, but 10 from 15 will give me 5. Now I just have to determine how I get the negative 5. So our product of factors for 150 is going to be 10 and 15. That will give me 150 for my constant term. Now, if I put a plus minus, I will get r times r, which is r squared. Here's a positive 10r minus 15r. A negative 15r plus 10r gives me a negative 5r. And I get my positive 10 times a negative 15 for my negative 150. Therefore, by just doing the FOIL method in my head, I'm going to get my trinomial factored into this product of factors, r plus 10 times r minus 15. The next trinomial, y squared plus 7y plus 12. Here our constant for c is greater than 0. So that tells me that my symbol for my product of factors is either going to be a plus for the positive 12 or a minus to get the positive 12. So let's break up the first term. Y squared will break up to y times y. Y times y is y squared. Now I need the product of 12. I need two numbers that multiply for 12, but when I add them, and I know I'm going to add because of the plus symbol in front of my constant, that I get 7. I could go through and start with 1 times 12, 2 times 6, but what I end up to get is 3 times 4. 3 times 4 is going to give me 12, and 3 plus 4 is going to give me a positive 7. That's going to tell me that this is not a minus. If it was, I'd still get my positive 12, but I end up with a negative 7. So I need to create plus signs for each. That will generate, when I FOIL, y squared plus 4y plus 3y plus 12. And that generates my original trinomial, y squared plus 7y plus 12. Our next example, b squared plus 9b minus 22. Again, I want to create a product of its factors by creating two parentheses. Here I have b times b, which gives me my b squared. I know that my constant term is less than 0. Therefore, that tells me I want to subtract these two values to get a positive 9, but I need these two values to be factors of 22. Therefore, they multiply to give me 22. We can start by 1 and 22. That will give me 22, but won't give me 9. But when I go to 2 times 11 will get me the value of 2 times 11 of 22. Now, I know when this is a minus sign, I either need this to be a plus minus to get me my negative 22, or a minus plus to get me my negative 22. But the order of my symbols have to get me a positive 9b. To do that, I'm going to let this be a negative 2 and a positive 11. And I can just keep checking to get this right. So when I do check by using the FOIL method, b times b is b squared. Outer gives me a positive 11b. Inner, minus 2b. And last, minus 22. When I simplify, that's going to get me b squared plus 9b minus 22. If it turned out that this got me a negative 9b, I would just simply switch the signs. The next type of trinomial we'd like to factor is called a perfect square trinomial. Here is what a perfect square trinomial looks like after it's been factored. Let's take a look at how we go from this product of a square binomial to a trinomial. Recall that when I have this binomial and it's squared, I rewrite it as x minus 4 times x minus 4. In other words, it looks like a product of its factors. Then I would simply FOIL x squared minus 4x plus 16. And I would get a trinomial of x squared minus 8x plus 16. And we have been factoring trinomials that look like this, but what we want to do is end up with a binomial squared. And we're going to get that after we get a product of its factors, and they turn out to be the exact same expression, that we can rewrite them as a square binomial. Let's look at a couple of examples. We want to perform the same operations we have been doing as on the previous slides of factoring. Here we have z squared plus 6z plus 9. Again, I have a constant term that is greater than 0. So I'm going to have a product of factors, two sets of parentheses. And I'm going to break up z into z times z, which gives me z squared. Since this is greater than 0, then I know that my symbols for my expressions are either going to be plus, plus, which would give me a positive 9, or a minus, minus, which would give me a positive 9. But remember, I need factors of 9 that, when I add, achieve a 6. So 1 times 9 is 9, but won't get 6. 3 times 3 is 9, and 3 plus 3 is 6. If I get minus, minus, that would give me a positive 9, but that would generate a negative 6. So I have to change these minus minuses to plus, plus. And when I FOIL in my head, z times z is z squared, plus 3z is 6z plus 9. Now, I recognize that these two expressions are the same and they are products, so I can rewrite that as z plus 3 quantity squared. So all this does is add an extra step to our solution. Our next example, again, a product of factors, two sets of parentheses. M will break up into m times m. This constant is less than 0, so I'm going to need a plus minus or a minus plus, depending on what value is giving me my positive 11. Now I have factors of 42. And factors of 42, 1 and 42 is going to give us 42, but not 11. 2 and 21 will get us 42, but not 11. And we also can have 3 and 14 is going to give us 42, and 3 and 14, when I subtract, will get me 11. So 3 and 14 will achieve my 3 times 14 is 42. Now I have to determine, is this a minus plus or a plus minus? And here I'm going to have a minus plus. And I can check that by FOILing. M times m is m squared, minus 3m plus 14m. 14 minus 3 will get me 11m. And a negative 3 times a positive 14 will get me a negative 42. I'm done with this problem because these two expressions are not the same and cannot be combined into a square binomial. Another two examples. Let's start with the first one. M squared minus 12m plus 36. A product of factors, two sets of parentheses. M times m. And when I take a look at 36, it jumps out at me that 6 times 6 is 36, and 6 plus 6, because of that symbol, gives me a 12. So I can write 6 and 6. Now I just need to determine, is this a minus minus or a plus plus? When I FOIL in my head, m times m is m squared. Minus 6m gives me a negative 12m, which is what I need. And a negative times a negative 6 gives me a positive 36. My expressions are the same, so I can write them as a square binomial. The next example, y squared plus 14y plus 49. Again, a product of its factors, two sets of parentheses. Y squared breaks up into y and y. This jumps out at me that 7 times 7 will get me a 49. But also, when I add, will get me 14. Here, I just determined is this a minus and a minus. If it is, then that would be a -7 and a -7y would give me a -14y. That can't be true because I need a positive 14y, so these must change to plus plus. Now, y times y is y squared, positive 7y. Positive 7y gives me a positive 14y, and a positive 7 times a positive 7 is a positive 49. Then I can write that as a squared binomial. Y plus 7, that quantity squared.